Right. Good afternoon, everyone. I'm Nikhil Bojja, and I'm with Machine Zone. We are a mobile gaming company, and this talk will focus on how we use machine translation, machine learning in mobile games, and there's a lot of words down there, but we'll hear a lot of stuff about crowdsourcing, gamification, active learning, and machine translation. So let's go slightly there. So Machine Zone, we're makers of the popular Game of War Fire Age. It's really popular on iOS, Android. It's a top-grossing game. It's been around for a couple of years. You would have seen a lot of ads featuring Kate Upton and now Mariah Carey. And it's a civilization kind of a game where you strategize, you work with other players, you build cities, attack people. There's a lot of social elements in the game. There is a lot of collaboration and interactive elements there. And the game is primarily on mobile devices. It's officially classified as a massively multiplayer online role-playing game, which you can draw parallels to some other famous games like Warcraft or Civ or some of these other games if you're familiar with them. So moving on, we worked quite a bit on developing a single global game. And the idea for this was to bring players from around the world onto one platform so that they can play with players across the globe. And for this, we realized that, hey, when you have a global audience, you need people to talk to each other. And within the game, a critical component of the game is a chat server. So you have a lot of people chatting with each other over this chat server. There's a lot of instant communication. And when you have someone from France talk to someone from the US, then there's different languages there. And for that, we needed to develop a translation system. And the whole chat and translation systems actually power a lot of in-game interactions, and they power the long-term relationships that form within the game. I mean, Game of War has been around for multiple years now, and the reason why these games run for multiple years is because people develop these social relationships in the game, and that's what retains them, and that's what makes them come back again and again. So at the bottom there, we have a small snippet from one of the chats that we see. That's actually one player telling his teammates, his alliance mates, that, hey, he's going to be hit by a cyclone in some minutes. He's going to peace out for some time. Guys, keep an eye out on my kingdom. So it has nothing to do with the game. It is literally people talking with each other, developing a social network completely unrelated to the game, but still connected through the game. And it's people discussing all sorts of things. It could be about things like these. It could be about weekend plans. It could be about life issues, what have you. And this develops the community, and the community is what drives the game. And it's a massive community. We have hundreds of thousands of players play this game at any given instant, massive amount of concurrency, a lot of real-time systems that drive this game. So we have a couple of screenshots here, and this actually shows you how real-time machine translation works. It's essentially a couple of screenshots of how the chat server looks. On the right-hand side, you have the English version or an English player. The left-hand side, you have a French player. And anything that you type gets translated in real time. And these are aligned by lines, and you can see how this varies. And if you look at some of these translations, it's going to become very clear that machine translation is a hard problem. And it's as old as speech transcription or any of the other traditional NLP or machine learning problems. And it becomes especially hard when you're talking about, when you have gamers talk about different things, because there's a lot of slang. And the slang actually affects, let's see if we can, yeah. The slang actually affects the translation there. And getting those in between your chats drops your machine translation accuracy significantly. And if you look at some more grammatical phrases, the translation is really good. So this was the main problem that we wanted to solve here. How do you make machine translation more accurate? And that's a huge machine learning problem, which combines well with natural language processing. So we come up with a specific need for normalization. And normalization is essentially the idea of converting slang into regular grammatical language. So normalization here is especially important because it's a mobile game. People are typing on a mobile phone, and people are busy playing the game. And they're not necessarily grammatical, and they intentionally do not want to be grammatical or accurate in spelling. In fact, we've noticed that most gamers actually turn off autocorrect on their phones because it stops them from sounding cool. It's a constantly evolving language. Slang evolves over time. So we've seen people use different abbreviations, different slang forms, which changes very rapidly. We've seen regional linguistic influences. Like players in New Zealand seem to have a different kind of a slang because they're mixing Maori words with that. Players in South Africa have a different kind of slang because they're mixing Afrikaans words. And yeah, people use a lot of emojis. So all of these are issues which drops your machine translation accuracy, makes text understanding hard when you translate text. So to solve all of these, we developed MZ Transformer. It's a social media text normalization system which tries to address this issue. But as any machine learning system goes, to train a system, you need data. And it's really hard to get data that can solve this kind of a problem. Here we have slang text which needs to be converted to grammatical text. And it's really hard to manually generate this data. A, it's very expensive. And B, you could use some crowdsourcing systems, but not many people are familiar with this kind of a lingo. And C, you need this data across multiple languages. It's easy to get it in English, but very hard to do this across other languages. So we needed to create a lot of abbreviation lists, spelling error lists, and a lot of contextual grammatical information lists. And also, there are some data sets that have been developed using Twitter data, but the domain for this data, which is gaming, significantly varies from Twitter. I mean, the amount of slang used in gaming is much more than on tweets or on Facebook data. And also, if you look at the average tweet lengths, Twitter averages around 74 characters per tweet. The chats that we have average around 35 characters. So that gives you a very limited context. So for a machine learning system, that's again another complication to solve the problem. So it's a gaming company, why not just gamify this? So we utilize crowdsourcing plus the game economy to collect this data. And it's a real-time strategy game, and we have a lot of, we have an in-game economy with which people, in-game currency, which people use to buy in-game items that helps them progress in the game. So we leverage that currency, and because it's a competitive game, we create this feature where we have people enter some data for us, and we give them some of these rewards. So this is an example of the crowdsourcing system. On the left, you see a slang version of a sentence where people can enter the corrected version. It's similar to Mechanical Turk, but it's integrated inside the game. And in exchange, we give them some rewards for correcting this. And another way you can do this, you can select from a multiple choice kind of a system. So that's again the same system, but in Spanish. You can see some transformations like XKE being porque. So this is how we collect data. So once we collect data, that's exactly how it's going to look. You're going to have a source sentence and multiple target sentences. And you have multiple people agreeing on one particular hypothesis. And just by selecting the one best hypothesis, we are collecting a parallel corpus of slang to grammatical text. So yeah, that solves the data problem. And using this huge parallel corpus, we build the MZ Transformer system, which contains abbreviations, contains how to handle spelling errors. It extracts a lot of phrase pairs from these parallel data sets. For example, if you look at these two, you can always associate that what's up is what's space up. So you learn these kind of phrase associations. And we build a hidden Markov model-based normalization system on this data set. So we align certain words and phrases. We learn that this particular slang phrase corresponds to this particular grammatical phrase. And if you think about hidden Markov model systems, it's essentially a generative model where you have state transitions, and each of these words the probability of a grammatical phrase being a slang, probability of getting a grammatical phrase given a slang phrase, you find these probabilities in state transitions, and that's how you build a generative system. And then we also have a language model that, again, tries to make it more readable. So all of these come together in building a system that has been trained on data. So we have some BLUE score improvements. So this is a machine translation metric. It's traditionally used, and across most languages, we've seen improvements in machine translation by adding the hidden Markov model-based normalization system. And in translation circles, even though it looks like a couple of points of improvement, that's actually a big deal. And there's not really accuracy numbers, it's a different metric. So yeah, normalization helps, it's useful. We learned a lot of interesting things here, that we could leverage in-game economy to build something like a Mechanical Turk style crowdsourcing system. We learned a lot of things across languages. For example, we learned that MDR is the equivalent of LOL, and that's just one example, but hundreds of word associations like that across languages, which improves the way in which you can translate across languages. Some interesting things like we used 1 best hypothesis versus 10 best hypotheses. So 10 best hypotheses would be one source and 10 different outcomes that people submitted through the system. It caused overfitting, which goes against traditional machine translation techniques, because more of these hypotheses improves your system better. And the other cool thing was we were able to build these systems across multiple languages. Because there were a lot of players playing the game from across the world, we were able to build normalization systems in French, Spanish. It's over 20 languages. And yeah, overall, the other important aspect was it's a system that learns actively. The data that is collected, that's a continuous process. And we retrain the system over a limited period of time so that it keeps improving with the additional data coming in over time. And every time we release this feature in a new language, we start collecting data in the new language. Once we hit a certain threshold, we train the systems. So yeah, that's pretty much what we did. If you have any questions, I can answer them.
Thank you. Here for a Q&A. There's one here.
I had a question. So how it is different from the Google translation?
Yes. So Google translation is across languages. So you give it an English sentence, it gives you a French sentence. So we try to do the same thing. You give an English sentence, you get a French sentence. But Google Translate or any general purpose translation system is not very accurate when you have slang text. So when you give a slang English sentence, the French that you're getting out of Google Translate will be significantly worse than a grammatical sentence. So we added that pre-step before machine translation, where you convert slang into something more grammatical, and then you translate it to get a better output.
Cool. Hi, just a quick question. Regarding I think it was like an efficiency metric that you had up regarding the translation.
Yes.
What's the mechanism that you guys use to to sort of validate that? Like, is there a feedback loop from the users, or is it you just have a team of diverse backgrounds that are, kind of validate? If you could
Sure.
give a little insight on that.
Sure. So we try to use blue scores because, we don't have the linguistic expertise. We don't have a feedback loop from the players as such. I mean, technically, if you look at a feedback loop from players, they're usually not happy with anything that's not 100% accurate. So we keep hearing that translation sucks, but they still like it. They still keep using it. As about the metrics, yes, we pretty much rely on statistical methods. The whole system, which is an HMM-based system, we run it. We are generating statistics across multiple languages and building and modeling that. None of us know any language other than English for a good reason. And even those blue scores are supposed to help us gauge the improvement in our system. So if the score goes up by at least half a point or 1 point, it results in a significant improvement in readability. And there's a high correlation between those scores and human annotated scores. So we didn't really go into human annotated scores because it's just expensive, it's hard to do across that. So usually most MT systems, be it Google Translate or Microsoft Translator, they all compare systems using that particular metric.
How do you correlate across languages?
How do we correlate?
So how do you know that LOL is MDR?
Right. So that comes from the parallel corpus. Like we have the English version and the French version, let's say. Now you have the translated version and the untranslated version. So you line them up and you say, let's say in English, you say, LOL, that was really funny. In French, it could be MDR, something, something French. So you can, when you align them together, you see that this particular word position is occupied by that particular word. And you see this trend across a whole corpus. That could be thousands of sentences. So you learn from that. So that's called word alignment, and that's where machine learning comes in. You learn that this particular word or this particular sequence of words corresponds to this particular sequence of words.
So you create kind of dictionaries of intermediate words, so you have unique value markup across languages.
Yes. So once we learn these, once we have a reasonable confidence that, hey, this seems to be an accurate pair. Again, we don't know the language, so we pretty much rely on the model's confidence scores to see that, okay, this might mean that. Then we build static lists out of that. But that's only one half of the system. The other half is still the HMM-based system, because the interesting thing with language is you're always getting new things. So sentences are always constructed in different ways. So you can't always build a static list for the whole thing. So we always have this context-based text normalization system, which looks at the whole phrase, gets in all the context, and then tries to translate that.
Any particular languages which are notoriously difficult?
Japanese, Korean, traditional languages that are difficult in any NLP problem because the construction is different. And Latin languages tend to be easier because they're similar to English. You can get more data.
So how long did it take to build to the point that it was actually commercially useful in elapsed wall time and man hours or man years?
Right. So I would say, so one good thing with the crowdsourcing system was that initially we gave out a lot more rewards and got a lot more data really quickly. So we have that option to modify the rate. So you can give out more rewards, more people are interested in doing this very quickly. So you can generate 1,000-line corpus in a day very easily if you give out more rewards. So we did some of that early on, and it was a matter of months before we developed the initial systems, and we have been learning on that ever since.
This question for me, mostly, again, I'll ask the other NLP people as well, is why not open source it so that you can share the corpus? You spent a lot of time building it. You'd have loved to have a ready-made corpus available.
Sure. So one reason why that might not help much is it's a system that's tuned very much to this particular domain. Like I mentioned, there's a lot of open source Twitter datasets, and that's not very useful. I mean, it's somewhat useful, but not very useful for us because most NLP systems, they perform best when you tune it to the particular domain. So for that reason, and also this is essentially chat data, so we haven't really looked at could there be privacy issues or those kind of things in open sourcing that. So it's something that we thought about, but haven't really moved in that direction yet.
Thanks a lot, Nikhil, for the awesome talk.
Thank you.
It was very informative. Round of applause, please.